Hello, everyone. Welcome to the DI 101 webinar series. This series is a great resource offered to Distribution International customers, partners, and associates. By partnering with our manufacturers and our industry experts, these webinars deliver very informative presentations about industry trends, new technology, new products, and product applications. Today, we are very excited to partner with Knauf for today's webinar. Representatives from Knauf will present an overview of technology, traditions, and trends as it relates to fiberglass insulation suitable for high-performance, sustainable projects and a wide variety of applications, both in commercial and industrial projects and environments. Various forms of foam glass, its sustainability for a variety of building types, systems, and conditions, along with current needs and trends in the industry, are to be discussed. Let me introduce our presenters. We have Daryl Peel. He holds the position of Business Development Manager in Commercial and Industrial for Knauf Insulation serving North America. Currently a member of ASHRAE and Astm, he serves on several committees related to mechanical insulation systems and components. He is the current chair of NIA's Technical Information Committee, a past chair of ASHRAE's TC 1.8 Handbook Committee, and a member of the editorial committee of the National Commercial and Industrial Insulation Standards Manual, also known as the MICA Manual. Mr. Peel has been associated with the building mechanical systems industry since 1982, holding various roles in the contracting, distribution, and manufacturing segments of the industry. During that time, he has served in several positions requiring in-depth work in business and product development, systems design, specification, standards, and codes applying to a wide range of applications. We also have Michael Stoner, Regional Specification Specialist for Knauf Insulation. He holds the Construction Documents he holds the title of Construction Documents Technologist from the Construction Specifications Institute and Lead Green Associate designation from the USGBC. He has been in the building materials industry for more than 20 years, the majority of which focusing on fiberglass insulation, serving all constituencies from distribution to installing contractor to specifying design professional. We are proud to have Knauf present today, and we thank them for their time. We will pause for questions at the halfway point of the webinar, and then we will do so again at the end. To submit questions, please use the questions tab on the GoToWebinar control panel. You can submit your questions at any point during the webinar, and we will answer the questions during those two question periods. Without further delay, I will turn this over to Michael Stoner with Knauf Insulation. Michael?
Hey, thank you, Jared. Really appreciate that introduction and the opportunity to present here today. This is Michael Stoner. I want to thank also Distribution International for putting this event together and for the effort to coordinate an educational series that really allows many facets of our industry to participate. Look forward to sharing information, having a good interaction this morning or afternoon, depending on which part of the country you're in. And first off, welcome. Hello to everyone out there in webinar land. I appreciate everyone taking time out of their day to join us. Want to emphasize, if you do have questions, please submit them in the box that Jared referenced, and we'll do our best to answer them accordingly. Here's our table of contents for today's session. We'll start out with the presumption that most people on this call have some familiarity with Knauf Insulation. We want to expand on that understanding and provide a little more backstory as to the origins of the company and the manner with which we've grown to be the global manufacturing leader we are today. From there, we'll get into a discussion on traditions in our industry. This will include information on ASTM standards, sustainability, and some green building programs. Next, we'll look at a number of building types, building systems, both commercial and industrial, and some of the trends being seen in the industry. We'll close out our session with a Q&A, so as Jared mentioned, please put your thinking caps on, and don't be shy if you do have a question for us to answer. If you're thinking it, there's probably somebody else that has that on their mind as well, so we'll do our best to get you the information. So, Knauf Insulation North America. Knauf Insulation is part of the Knauf Group. We're a global manufacturer of building materials and construction systems. The Knauf Group was established in 1932, originally as a producer of conventional gypsum materials. Over the past 85 plus years, we've consistently expanded and today provide innovative building solutions worldwide. The global headquarters is located in Germany. Currently, there are over 27,000 employees and 220 factories in more than 80 countries. The Knauf Insulation part of the Knauf Group was established over 40 years ago, headquartered in Shelbyville, Indiana, which is about 45 minutes southeast of Indianapolis. Currently, Knauf Insulation has over 5,500 employees and 6 plant locations in the U.S. The company is independent and 100% family owned. And the next slide is going to show a little bit more of the company history and corresponding milestones. As you can see in the blue box on the right, Knauf Insulation was established in 1978 as Knauf Fiberglass. This was through the purchase of an existing fiberglass production facility in Shelbyville, Indiana. Later on, the company expanded operations and renovated manufacturing facilities to eventually become known as Knauf Insulation. A couple important milestones on this page I want to highlight. One is Knauf Fiberglass becoming the first insulation company to earn Green Guard certification. Also want to point out the introduction of ECOS technology in 2008. This is a topic I'll expand on in the upcoming slides and want to delve into that a little bit more. Lastly, I want to call attention to the acquisitions Knauf Insulation has made over the years. This includes Guardian Insulation in 2014 and USG earlier this year, which further positions Knauf as a leading global materials company. So what has Knauf done for fiberglass? Here are 5 specific examples. It begins with the introduction of a bio-based binder. This is a manufacturing change made worldwide, which as I mentioned, I'll get into some of the particulars in the upcoming slides. An additional example is formaldehyde-free. In our presence we have Knauf Insulation offers more lines of formaldehyde-free fiberglass insulation products than any other insulation company. This includes applications for the mechanical space as well as pipe and equipment offerings. With regard to recycled content, our plants use 60 to 80% recycled content. This reduces the energy required to form glass fibers by 20% and reduces mining impacts by 60%. One interesting fact with Knauf Insulation is we utilize 10 rail cars of recycled glass each day. As far as biosolubility, Knauf has consistently addressed the long-term health and safety concerns of fiberglass. All fiberglass made by Knauf Insulation is audited by a third party, which ensures biosoluble chemistry from a health and safety standpoint. Our ASJ Plus jacketing. This is the newest generation of all-service jacket composed of aluminum foil reinforced with a glass scrim bonded to craft paper with an outer film leaving no paper exposed. ASJ eliminates concerns often found with paper ASJ. It allows improved cleanability and is moisture resistant to intermittent liquid water exposure during the construction phase. Okay. So the title of the presentation is Fiberglass Insulation, Technology, Traditions, and Trends. Here's where we get a little into technology. In particular, I want to talk about ECOS technology. And like Knauf Insulation, this is a term a lot of people might be familiar with, but may not know a lot about. ECOS technology is a revolutionary binder chemistry that enhances the sustainability of our products. The binder is the bond that holds the fiberglass together and gives the product its unique shape and brown color. ECOS technology is a plant-based, sustainable chemistry that replaces phenol formaldehyde binder traditionally used in fiberglass products. Products using ECOS technology are formaldehyde-free, have reduced global warming potential when compared with other products in the past. Some of the key benefits of ECOS technology is based on a rapidly renewable resource. The bio-based formulation does not contain phenol, formaldehyde, or acrylics in the process. The reduced impact on the environment through lowered embodied energy. There's a lower process emission inside the plants, and externally there's a reduced manufacturing emission to the environment. Improved indoor air quality is often found in product application, and no artificial colors or dyes are added to this technology. The next slide references how ECOS technology works. It works by converting bio-based or plant-based material into a polymer, and through a proprietary process is used to create an incredibly strong binder that bonds not only fiberglass insulation, but also other materials. Once again, this process eliminates the need for formaldehyde and phenols, often found in the traditional binders. So now we're going to pursue the traditions path of our presentation. I'm going to hand the presentation over to Daryl, and he's going to get into a discussion on some ASTM standards. So take it away, Daryl.
Oh, thanks, Michael. And again, reiterating what Michael said earlier, this is Daryl Peel. Reiterating what Michael said earlier, we appreciate DI hosting us and allowing us to participate in their educational series. We hope everybody finds what we're presenting here useful in some form or fashion in their business. That's our goal when we do this kind of education. So we'll move into some of the key standards that apply to fiberglass. As Michael said, from a tradition standpoint, these standards have applied to fibrous or fiberglass insulation for many, many years. They continue to evolve as the process of consensus review takes place within ASTM. So even though they're historical, they do get updated on a routine basis, and we're in the middle of that process right now on this particular stand on the C547 standard. So anyway, ASTM International, I'm going to do a quick introduction here, used to be known as American Society of Testing and Materials. As they redefined their role in the world of voluntary standards development, they selected to expand their role and delve into some areas that were outside just materials. So hence renamed themselves ASTM International. As I put down below, they are a voluntary standards developing organization. There's no government initiative behind this. It's all members of ASTM literally sitting around tables and talking about these standards, what's in the standards, what ought to be in the standards, how maybe they should change. We do develop technical documents that are the basis of manufacturing, management, procurement across a whole segment of industries. I happen to be on fire safety, the insulation segment of things, and then there's one that's devoted to shipbuilding that I participate in. Anyway, the ones that apply to fiberglass are shown on the screen here. ASTM C547 for pipe insulation. That has a couple of divisions in it that are separated by the manufacturing process that's used to produce the pipe insulation, the service temperature that the pipe insulation is approved for, and the application process used by, directed by the manufacturer for installing the pipe insulation. ASTM C553 is the specification for mineral fiber blanket insulation. This covers blankets used industrially. It does not cover building insulation products either used for metal building insulation or typical BI structural residential type insulation materials. It's meant strictly for those items detailed in the title of the standard. Again, there are divisions of types and grades within this standard. Those types and grades are divided by use temperature and thermal conductivity. Then we move on to ASTM C612, which covers board and block insulation in fibrous form. One of the things I failed to mention earlier is this covers both fiberglass and rock fiber as well, or mineral wool as people know it. So 612 is also broken out into various types and grades, and the basis of decision on the types and grades that a product falls into is based on the use temperature, the thermal conductivity, the compressive resistance of the material, the linear shrinkage, the water vapor absorption, and surface burning characteristics, far more than the other two standards. And finally, there's Astm C 1393, which covers traditional pipe and tank insulation product. There are types and grades there broken out by use temperature, thermal conductivity, and compression resistance. There are two types of pipe and tank insulation covered by this standard at this point. That's the traditional lamella, which is the fiberglass boards that are cut, segmented, and then glued to a facing. And then the new continuous mat products that have been in the marketplace since about 1995 or 1996, which kind of look like what I'd call corrugated fiberglass that allows the material to be a continuous mat and yet maintain flexibility. So what specifically does Knauf have that are covered by each of these standards? That's the next subject here. Under C547 for the pipe insulation, both our jacketed product, the Earthwool 1000 with the ASJ Plus, and our unjacketed or plain pipe insulation are covered by C547. You'll notice that I made a note of grade A on that particular product, and the reason for that is grade A is one of those divisions within 547. Grade A products can be applied directly to a pipe operating at the full claimed service temperature. So in our case, where we claim 1,000 degrees service temperature, our product can be applied directly to that pipe without the concern for exothermic or additional heating reactions driving the pipe insulation past its rated service temperature. There are grade B products where there is a startup schedule so that the binder burnout or the decomposition of the binder doesn't exceed the service temperature of the pipe insulation or that exothermic reaction that we talk about. On C612, we've got our regular insulation board, runs from 1.6 pound to 6 pound density, all facings. Then we have our 2,000 degree flexible products, our elevated temp panel, our elevated temp board. Then finally, C553, we come on our atmosphere duct wrap, which falls under C553, blanket material, and then our elevated temp products that are highly flexible and meant for forming around high temp surfaces. And then C1393, we do provide the two types of pipe and tank insulation that exist in the marketplace, both lamella, which is the fabricated board product, and our quick flex, which is the continuous mat flexible product. At this point, we've already reached the breaking point for our first question and answer session that Jared had made reference to. So I would say we probably ought to turn it over to Jared to handle the moderation on questions at this point.
Thank you. And just a reminder, to submit questions using that questions tab in the GoToWebinar panel. We do have a few that have been submitted. One asks, can fiberglass be used for cold or below ambient systems as well as warm systems? And if so, how?
Fiberglass is definitely able to be used below ambient temperature. It requires a specific attention to detail in terms of making sure that it's properly vapor protected. The insulation, the fiberglass itself, provides the resistance to thermal transfer, and that's what we're doing here with fiberglass or any insulation material, slowing thermal transfer. But the vapor retarder stops the flow of water. Water is the biggest concern, or water vapor is the biggest concern with cold systems. You'll notice our product is, most fiberglasses even are rated down to 0 degrees F. So if you have a chilled water application and you vapor seal it properly, fiberglass is highly appropriately, highly specified for chilled water applications. We were just discussing ice arenas. There's a new ice arena that's going to be built in the New York City area for the Long Island or New York City Islanders. They are running glycol or brine as the refrigerant for the ice slab. Since that's still above a 0 degree Fahrenheit, properly vapor sealed, properly terminated at the piping specialties like flanges and valves, including vapor stops, you'll be able to definitely use fiberglass in those kinds of below ambient conditions.
Great, thank you. Another one, how long will fiberglass last in hot systems?
We've had fiberglass in operation for upwards of 30 years. I've seen fiberglass pipe insulation that's been in service for 50 years on hot systems. The perception is that in a hot system, there's a continual degradation of fibrous materials. There will be binder decomposition, thermal decomposition, up to approximately 350 to 400 degrees Fahrenheit. But after that, the fibers are going to stay in great shape. We've had plenty of examples of that. The fiber is long enough that it holds itself together and maintains its structure. And then one of the other things that happens is after the interface temperature gets below that 350 or 400 degrees Fahrenheit, the rest of the construction, the rest of the pipe insulation creates its own shell that helps hold the material together, along with that long fibrous structure that creates an interweaving to add integrity to the whole system.
Okay, another question submitted. Which blanket could be used in a marine environment? Navy, Coast Guard, etc.
Michael, do you mind handling that?
As far as the specific product, I think that there's a lot of products that have Coast Guard approval and could be used in that instance. As with regard to, I guess, a little bit more about the information as to the application, would kind of be necessary to really get down into what would be most appropriate. Oftentimes I'll look at a specification submittal or something like that that delves into the performance characteristics. So without being overly broad, maybe if that's one that could be captured and we could circle back to it as far as a particular recommendation for a product.
A little bit more on that. This is Daryl Peel again. The elevated temp products have Coast Guard approval for use on mechanical systems. If somebody is referencing hull board or hull insulation, that's a different set of approvals that's required. So mechanical systems, our elevated temp products meet the need, and then hull insulation, we do not have a product that has an approval for the use of a hull insulation.
Okay.
Now, I believe that it's possible that some of the other fiberglass producers or producer may have hull insulation approval. Normally a hull, though, is insulated with a board product, not a blanket product.
Okay, I think we have one more. How is resistance to crushing improved in systems?
You'll notice the references to systems. That's real key in this whole compressive resistance concern that is out there. The compressive resistance is improved in a system by selecting materials that have high compressive strengths. That may include inserts, such as you might incur in hangars. That could be including jacket materials that have high compressive resistance to crushing. But it's system selection and system material selection. One of the strategies that the industry has employed is to try to find insulation materials only that have high compression resistance, when in fact it can be a system assembly that provides that compression resistance while the insulation provides the resistance to energy flow.
Alrighty, I think that's it for this round. Again, you can continue to submit questions, and we'll come back and answer questions again at the end. But I'll turn it back over to you guys to proceed with the presentation.
This is where Michael introduces the subject of sustainability and green building, and talks to us about that impact in the industry at this point.
So voila, there's our title slide for sustainability and green building. Thanks, Jared. Thanks, Daryl. Appreciate everyone submitting questions. As we move on to the subject of sustainable and green building, I want to recognize that this is another topic with a fair amount of tradition. A lot of these programs have been in place for over 20 years, and there is some speculation as to what trends are to come. As insulation is a distinct component of sustainability, particularly as it relates to energy savings. While we're on the subject, I also want to point out some additional benefits insulation has as well. This slide represents some of these benefits. They include the use of insulation for process control. This applies whether a system's hot or cold. Insulation allows for consistent temperature to be maintained throughout a system. With regard to condensation control, insulation is often utilized to mitigate mold, lessen potential damage to ceiling assemblies, and prevent slips and falls due to pooling water. The use of insulation for personnel protection ensures that systems are maintained at safe levels in the event of contact. From a fire safety perspective, insulation can prevent small fires from spreading or beginning in the first place due to unwanted contact with hot surfaces. Lastly, the use of insulation for acoustical control is beneficial for eliminating unwanted noise. Moving forward, we'll look at some common green building and sustainable construction programs. What's depicted on this slide isn't necessarily a comprehensive list. What we did want to do is call attention to some of the prominent programs in the industry today and dive a little deeper as we move along. At the top of the list is LEED. LEED has consistently been one of the preeminent platforms for green building. What we'd like to do is look at some of their data in particular and maybe get a glimpse at some future opportunities. Brings us to these two charts. What's reflected here on the left are the cumulative LEED registrations to date. On the right, you can see the cumulative LEED certifications to date. You can see there's upward momentum throughout both of these graphs, although in the case of registrations, it's beginning to level off a bit. Still heading in a positive direction, just not with the sharp incline that's been experienced over the past 4 years since leading up to 2015. Could be in part to some movement away from LEED, or it could also be due to the increased number of green building programs in existence today. As far as projects are concerned, this graph focuses on 3 rating systems. On the left there are building design and construction, interior design and construction, and operations and maintenance. The corresponding project types and owner sectors involved are also included. This information is often helpful in the event that you have projects and you're trying to narrow down who's more likely to require certain green building products and which projects those products are most likely to go into. There's a combination of both public and private, but as you can tell, higher up on the list, there's definitely an opportunity in these spaces. Now, while we know there's some potential for bias when looking at data, so we also wanted to include information from a separate third party and see if they reflect similar green building trends. In this case, the next 2 slides here contain information from Dodge Data and Analytics, which is located in their Smart Market report on green building trends in North America. The graph here reflects levels of green building activity in North America in 2018 and expected activity in 2021 based on a study of design professionals conducted between April and June 2018. It's worth noting that the increased level of project activity being conducted by respondents, which have more than 60% of their project activity involving green projects, it's represented in the purple columns to the right of each graph. I also wanted to include some additional findings from this report, the Smart Market report. The bullets here represent some of these findings. In effect, green building activity continues to grow across the globe. The activity is increasing, but as we saw in the prior slide, not all projects are certified. Oftentimes the registration takes place and there's a increasing of some of the energy efficiency and benefits without in fact getting the plaque in the lobby. Growth in green is driven often by strong business benefits. There's a finding that owners are beginning to realize that green projects often result in higher rents and greater indoor occupant well-being. Client demands and environmental regulations are top triggers for building green, but really doing the right thing continues to be an important motivation. This may be due in part to the social responsibility that often coincides with green building. So as it appears that green building activity will trend positive in the foreseeable future, if this is the case, what standards or certifications should be taken into account? Or put another way, what product labels or programs are often utilized to recognize products which may be better suited for green building endeavors? On this graph here, this is a few that are worth noting. So all of the labels on this page represent third-party labeling and certification programs. Each has its strength, and you can find out a lot more if you look at their individual websites, but for the purpose of this call, I'll just focus on GreenGuard. GreenGuard is again a third-party certification and label program, happened to be established in 2001. Labels reflect varying levels of greenness or compliance, put it another way. Begins with GreenGuard Certified on the left there for low emitting products. It moves forward to GreenGuard Gold, which was formerly known as Children in Schools. This takes into account a higher or stricter certification criteria for those that might have a heightened sensitivity. And then UL Validated on the right certifies a particular product attribute. In this example, the label demonstrates a product certified to be formaldehyde free. Moving forward on the material transparency side, access to information today has never been better. LEED version 4 has brought material transparency to the forefront. So this slide highlights some of the additional methodologies that are utilized to help architects, specifiers, and other professionals to better understand a product's sustainable qualities and environmental repercussions. At the top of the list is an Environmental Product Declaration, or EPD. This is a comprehensive document that reports ways in which a product affects the environment through its life cycle. This is similar in concept to a nutrition label, but an EPD tells the complete sustainability story of a product in a single written report. Health Product Declaration is a similar type of report, but it consists of a defined format and instructions for reporting contents of a building product, along with associated health and other related information. The Declare program advocates for building product manufacturers to use the ingredients in their products to ensure healthier indoor living environments. It's also like a nutrition label for the building industry, much like an EPD, and effectively empowers customers to make more informed purchasing decisions as a result of product transparency. 3 questions in particular that a Declare label answers, as you can see in the image to the right. Where's the product come from? What's it made of? And where does it go at the end of its life? Living Product Challenge is a framework for manufacturers to create products that are healthy, inspirational, and give back to the environment. This is a newer campaign asking manufacturers to stand up for transparency and provide information about health and impact their products may have. The final 2 bullets on this page are organizations that provide a common platform for manufacturers to communicate transparency information. If you haven't looked at them, please do so. They're both free. These are great library resources if you have a product or company you want to explore and determine really where they stand insofar as the available information. This is a portal that has environmental product declarations, Declare labeling, and it's kind of a one-stop shop to find out certain manufacturers and products and where they stand with regard to transparency. And this brings us to Knauf Insulation. This slide depicts contributions to sustainable construction. It's kind of how we fit into the construct of green building and represents the various platforms where we actively participate. Now, having looked at some of the sustainability programs, I'm going to turn it back over to Daryl. He'll take it a little bit further insofar as some of the building types and systems that are involved, and lead us down that path. Appreciate it, and thanks. Take it away, Daryl.
All right, Michael. Okay, that's pretty in-depth, nice overview of what's going on within the sustainable and green building world at this point. Michael's a great resource, and as he said earlier today, it's kind of a special interest of his, so feel free to tap him. He might actually have a little more information for you. In terms of types of buildings and systems, the reason I wanted to revisit this a little bit is at times we have a tendency to forget where fiberglass is applicable, how it's been used in the past, and how it can be used in the future. So I broke out a detailing of these types of buildings and these types of systems within the buildings. And without further ado, we'll start into that segmentation. The first kind that we picked on is commercial buildings. What is a commercial building? Well, it's typically characterized by its occupancy. There are many subtypes of commercial buildings beneath each of these major sectors. These major sectors are what the United States Census Bureau uses to track commercial construction, non-residential, I should say, building construction. They break it out into terms of commercial and then track how many permits and how many actual dollars are put in place. And these are the major segments they use, and these major segments are broken into many smaller segments. But anyway, the general characteristics that define this type of building is its occupancy. The occupancies are generally the general public is going to somehow access these buildings. They're going to have higher concentrations of people on, let's say, a per square foot basis, typically. They'll be extended in their time in that structure. Some of these are office buildings, education facilities. You'll notice religious or churches as part of this. People spend quite a bit of time inside those structures. Then you have very fluctuating sets of occupants. People come, people go, so the turnover is high. As far as the systems and the service in these structures, the services that our materials and fiberglass and systems are subject to are far less severe than the industrial environment. They don't have the extremes in conditions, the environmental conditions or the operational conditions that other segments of the building business contain. And finally, there's nowhere near the amount of risk. These are very low risk kind of systems for, and when I say low risk for catastrophic failure. And when it does happen, if a catastrophic failure does happen, it's highly, highly unusual and highly studied to try to figure out why that happened. So what sort of systems are in these buildings that get insulated? If you'd move along to the next slide, Michael. We have lots of pipe systems and equipment and duct systems and equipment. These are all highly traditionally insulated with fiberglass, and fiberglass is serving well today. The photo on the right was a picture of a structure that a lot of our product was used in. I took that photo earlier this year. I was walking through the mud. That project was nice and muddy. But anyway, we have lots of HVAC piping systems and equipment, all carrying either heating or cooling fluids or heat transfer medium of some kind or another, and the associated equipment. Duct systems, air is a heat transfer medium as well to heat and cool spaces that people occupy. Fiberglass does a great job in terms of heating, insulating the supply return and it fans there. And then on the plumbing side of things, the domestic water, both hot and cold, the pumps, the piping specialties, backflow preventers. Then we have the drain and waste systems that quite commonly need insulated. Fiberglass has been a very traditional material in these systems and continues to serve well and provides excellent performance when insulating these systems. We'll move on to the next type of building that is tracked in the non-residential building segment of the construction industry, the industrial world. In the industrial world, again, we have these major divisions with many subdivisions beneath them. The characteristics of the industrial facility is typically there are a specific set of occupants in this building, usually the employees. There's nowhere near the concentration on a per square foot basis that there is with commercial work. The occupancies are typically shorter in time and number or lower in time and number. Then as far as the systems, they're typically very process oriented. They're not necessarily space conditioning oriented. They're highly necessary to the business. They take more space usually than the personnel do because that's the reason the building exists. Then as far as the services of these systems, they're normally far hotter, far colder, and the potential impacts from catastrophic failure are far more severe. Hence, we need to think more durable, stronger, a different mindset when insulating the systems in these buildings. So let's move along to the building system types. Again, fiberglass has a long history of insulating in the industrial world, even though there's other products out there that have come into the scene recently. All these types of systems can be handled by fiberglass simply because fiberglass does have such a wide service temperature range. Again, 0 to 1,000 for us, 0 to 850 for other people. But most of the piping, and we try to estimate this quite often, and it comes out to be 90 or 95% in most cases, is covered by fiberglass, and they can handle pretty much any kind of system in an industrial environment. So at that rate, I'd like to move off to the next subject, which is kind of concerns and trends in the both segments of the non-residential building segment of construction. And that's the industrial owners' concerns. Right now, their most concern, highest level concern, is corrosion under insulation, and they're interested in systems that will not contribute to corrosion on systems, and preferable, they'd like to see systems installed that can help them control that corrosion. Then the next highest concern, as you see, is moisture and moisture transport resistance. And the reason for that is moisture in the building destroys facilities and creates personal hazards in terms of potential slip and fall, as we talked about earlier. And mold and mildew growth is also a personnel hazard they need to recognize. Compression resistance, it avoids costs in their building in many ways. Predominantly, it keeps the energy savings as the energy savings are supposed to be, and it keeps critical systems or critical processes operating the way they were designed. Fire resistance, if a fire breaks out, insulation systems are used to limit the damage associated with fire, keep critical systems operating in the event of a fire, and most importantly, control the start of a fire, stop fire from beginning. And lastly, it's used as a life safety measure, giving people the opportunity to vacate the building in the event of fire. Then finally, reduce first cost of facilities. Insulation or fiberglass insulation gives them the ability and the desired characteristic of a fast in-place service, and they're also looking for enhanced ROI. So let's move along to the next slide that determines, or not determines, but details how fiberglass contributes to those goals. We have multiple corrosion tests, more so than any other insulation material out there. That allays the concern of corrosion under insulation to some extent. The water-resistant jacket of ASJ Plus helps control the intrusion of moisture into the system. The compressive recovery, we do test by C165 for compressive recovery on some of the materials so that a designer can pick a material that creates a long-lived insulation system. Limited combustibility, it's often unknown that fiberglass has undergone so much fire testing to demonstrate its inability to support flame and smoke. Then we do provide that fastest installation and lower labor as much as 30%. That does create shorter lead times to get the building in production and improve that ROI that the owner is looking for and put the facility in production. So trends in the industrial world is the next slide. And as much as the community has done to demonstrate corrosion mitigation and non-contribution, it's still a top of mind subject. Lots of research is being done, a lot of discussion among trade associations and in trade publications. A high level of awareness has been created towards corrosion under insulation, and many technologies are being developed, even in our own business, to help avoid corrosion under insulation. Little number kicking around the industry, folks, is that upwards of 10% of a facility owner's budget, maintenance budget, is devoted to mitigating corrosion that has happened. And to do that, they've got to kind of dig through our insulation and uncover it first. So the next items on the hit parade are greater energy savings. If you'd back up again, Michael. Greater energy savings. They want to get the cost of those operations of their facilities down. Energy savings, particularly in the form of insulation, is an easy win for facility owners. Reduced emissions. We certainly want to meet environmental regulations, and then increased heat retention is key. That falls in our realm of responsibility. And you can see the others: increased moisture resistance, system strength, wider operating temperature ranges, all for the reasons that we talked about. They still want to drive the cost of facilities down and get them up and running quicker. Okay, Michael, next slide. Commercial side, pretty much a lot of the same concerns. The ones that are a little bit unique are ones that are related to occupancy, which is the desire for formaldehyde-free, and the use of sustainable building standards. As far as the trends that we see, again, reduced installed cost to create better ROI. One of the things that's happening is more compact and higher capacity ways to get that comfort delivered, and then flexibility in the space. There's a lot of desire for having a hot, one warm room, the other warm room cooled, and creating systems that can do that. There basically are the key concerns and trends in both commercial and industrial. If we go to the next slide, we wanted to introduce a program that is very successful, very helpful in sorting out thicknesses. It's 3E+, written by the North American Insulation Manufacturers Association. We have a copy of it on our website at that web address, at that URL that has Knauf materials plugged into it already, the thermal conductivities. The key use is to help sort out cost-effective, good performing systems that can achieve the goal of the owner designer. Here we ran two calculation examples. One is the cold side condensation control. The other is the warm side personnel protection. As you can see, we were able to compare various systems and the thicknesses required to achieve the goals. And it's a commonly used tool in the industry. If you're doing a lot of thermal calculations for these reasons or to determine proper thicknesses, definitely go download 3E+. Okay, at that rate, we're going to talk about how Knauf can contribute, what kind of performance we can bring to the party. And this applies to a lot of fiberglass. We provide superior in-service integrity and durability. We talked about earlier how that is achieved. Better energy control. Fiberglass delivers one of the best thermal conductivities in this industry. And it's been independently measured that way. Many tests have been run. For the money spent, we provide great energy control. As far as contribution verification, you saw the testing. It's well done. If anybody asks, we certainly provide significant demonstration of a lack of creating that corrosion everybody's concerned about. Certainly we meet the specs, and we certainly have the cost advantage, delivering that low first cost, low operating cost, and best ROI. So anyway, Michael, going to give it to you and let you run down through the resources.
Yeah, we just wanted to kind of close out our presentation here, understanding that there are probably some additional questions that'll come up down the road. At the top of the list here, if you would take a note of our email address. This is just contact information that you can touch each of Daryl and myself independently. Feel free to forward any questions, or if you need additional information about any of the content contained thus far, please don't hesitate to reach out. The items referenced below, Daryl touched on NEMA, and that's a wealth of information in and of itself. You can dive into that and certainly find a lot of frequently asked questions and tutorials that are beneficial in our industry. NIA, another resource worth taking a look into. USGBC, I've just referenced there, given their presence and ongoing position in the industry. And Sustainable Mines, I would encourage everyone to check that out as well. It is a free service and a great library when it comes to material transparency. And if you want environmental product declarations or any documents, there's a project builder, and it's a really clean system that enables you to access information without having to go to half a dozen different websites in order to do so. So with that, we'll turn it back over to Jared, and do want to take just a second to thank everyone again for the time to get on this call. I know it's a ton of information to jam at everyone in a short window, but appreciate the opportunity to get the ball rolling, and we'll give it to Jared for questions.
Thanks, guys. I really appreciate it. There's some really good stuff here. We do have a couple of questions that have been submitted. First, could you please repeat the free portal name for identifying product, declaring manufacturing ingredients?
Yeah, no problem. I'll take that one. I just referenced it, so I'll step back one slide here. At the bottom, I think this is the question that's being asked. SustainableMines.com. If you go there, unlike a lot of sites, you don't have the need to create a login and a unique password. That's the benefit of this particular portal, is you just go there and enter if you've got a particular project, or if you've got a manufacturer you want to look into in particular. It's pretty straightforward. So there's that one. Earlier on, I mentioned Mindful Materials. That's similar to this. It's just mindfulmaterials.com. I think you have to create a login in order to access that, but it's also a pretty robust platform to obtain documents. And as I mentioned just a short while ago, it's a place that you can go to get information in one location, as opposed to having to go to a variety of different places to access information.
Okay, the next question. Does fiberglass piping cover require oversizing of thickness when there is an electrical heat tracing cable?
Yeah, it does. Some producers will tell you go ahead and squish the insulation over the heat trace cable. Most preferable, and make sure that you got proper thermal control and proper fit, is to oversize it. When you're using heat trace cable, if you've got a single run of it down the pipe, that adds a 1/4 inch, and usually you can do that by stepping up by 1 pipe size. So if you've got an 1.25 inch steel pipeline, then you can step up to 1.5 inches and cover that. If you've got a spiral wrap or multiple layers, that's going to add an extra 1/2 inch thick or 1/2 inch to the OD of the pipe. So you'd want to step up whatever that might be. So if you've got a 1 inch pipe that's 1 3/8 OD, then you step it up a 1/2 and you 7/8 OD. I think that should cover it.
Thanks. And let's see. How can R values change for different sizes of pipe insulation of the same thickness?
There are 2 methods for measuring thermal conductivity in our arena. One is flat sample testing, and the other is pipe insulation testing, which tests the product in the round. The flat sample test eliminates any air spaces, and the round test allows for air spaces both on the inside as well as the outside. Those air spaces and that air film acts to help increase the insulating capacity of the system. And then the other concept that's employed in the C335 round pipe insulation test is that the inside diameter is far smaller than the outside diameter, so that the amount of BTUs conducted through that material is spread over a greater surface area on the outside, thereby increasing the insulating capacity of the material.
Alrighty, I think that is about it. Just double checking. Yep. So I think we're good. Gentlemen, thank you so much. Did you have anything else you want to add before we close this out?
Well, one of the things I would like to add real quick, Jared, is that this was designed to be a very, as the kind of the title of your series indicates, a very 101 type of overview of fiberglass in the mechanical insulation world, how it contributes, what its place is, how it's been used. A lot of those basics. The subject of fiberglass insulation is far deeper. The subject of mechanical insulation is far deeper. When you're moving into the 200 series classes, we'll be more than happy to bring some deeper material, and please contact us. There's a lot out there. Use the resources that we put up on the screen. Those resources dig into the material way deeper than we did today, but we wanted to take some of those folks who this may be new material to, kind of give you an overview without digging too deep into the subject. And for those who are more tenured in our business, maybe bring some ideas to light that weren't there previously, or we've forgotten as we've moved on down the road and heard all the noise in the marketplace.
Let's see, I'm sorry, I got one more question. Let's see, as industry codes change, especially with regards to thickness, do you expect that manufacturers of different insulation materials will have to enter into deeper levels of collaboration in offering products to the marketplace?
Yeah, I believe so. I think that that's going to be a next step in what happens regarding developing systems that can achieve all the goals of each of the segments we talked about, plus, as the questioner is asking, meet the desires, meet the needs of code requirements, codes and standards. I know that other manufacturers are working at developing ways of achieving the more stringent insulating requirements, and Knauf is no exception. It's certainly something going on in research labs around the country among more materials than just fiberglass, guarantee it. Anything else?
Okay, last one. Is it fair to compare condensation control thickness when using Knauf specific data for fiberglass versus generic K factors for elastometric?
That's one of the faults of the, I wouldn't even say faults, it's just one of the uniquenesses of any thermal calculation program, be it 3E, any proprietaries. The real performance characteristics are real key. I'd strongly suggest for anybody using any thermal calculation program or thickness calculation program, load the manufacturer specific data. The data reflected in 3E that's supplied by 3E for any given material is ASTM maximum standards. It may not be reflective of the individual material's real performance.
Thanks, guys. And I'll tell you what, I was asked if you could bring the slide up with your emails one more time. And
Well,
while there you go. And while you're doing that, we need to draw for the door prize. And if you could pick a number between 1 and 36. Let me get my random sort here.
Go right in between, in the middle. Let's go number 18.
Okay, that'll be Jason. So Jason, I will contact you directly after the presentation. Congratulations on winning the Yeti cooler bag. We will try to do door prizes with each of these webinars. So thank you to everybody for attending. Please follow us on LinkedIn to get updates on future webinars, or check in on our website at distributioninternational.com. Thanks again to Knauf for partnering with us on this today. And I hope everybody enjoys the rest of your week. Thank you so much.